This is going to be a rundown of the tech and the UX of a feedback form I made for a local business that sells art prints at a shopping center. The real life UX is that they receive their printed artwork and the store clerk asks them to scan the QR code using their phone and to fill out a short feedback form. This is the page that appears once they scan the QR code. All of the steps have text in two languages, Latvian, which is the local language, and of course English. The first step has a star rating. Selecting the rating automatically transfers them to the next step. But if they misclicked, there's still obviously the option to go back. The second step prompts them to select an option of how they came across the store. Finally, they're greeted by a text area asking them to give a more detailed explanation about what they liked about the store and what could be improved about the entire experience. The idea behind the ordering of the steps is that each subsequent step requires more investment from the customer, increasing the likelihood that they will finish the form or at least give as much feedback as possible. After a short timeout to prevent accidental submissions, the submit button begins to pulsate, making it very noticeable that they need to click it. Once they click the submit button, they're greeted by a thank you page. And crucially, even if they try to click the refresh button, they're still greeted by that very same thank you page. One of the main focuses I wanted the feedback form to have is to require as few clicks and or screens as possible. So I didn't want there to be a separate QR code that they need to scan for each language, a screen which prompts them to select their preferred language, or even anything like a language selector button at the bottom of the screen. If this were a country where at least four languages were a necessity, I'd opt for a language selector button or perhaps a flag at the start of each line of text. The original inspiration for the UX of the form came from Typeform, a service which one can use to build various forms and preview them instantly. I built an initial prototype using Typeform, but immediately saw several improvements I could make. I liked how each step in Typeform animates into view and implemented my own horizontal version of the animation. However, I disliked that on step 3, you have to manually click on the text area to make it focused and to make the mobile keyboard appear. Also, after you're finished typing, it could be smoother if you didn't have to click somewhere to make the keyboard disappear before being able to go to the next step. One problem I encountered is that with each step animating in, I couldn't get the text area to focus with the mobile keyboard appearing. The text area would show styling that it indicated that it is focused, but only a manual click on it would actually open the mobile keyboard. This was the behavior on iOS, and on Android it was something slightly different, but also not ideal. When I removed the animation, the keyboard and the focusing worked as intended, so I judged that to be more important than the pretty transition animation, so I just got rid of the animation. Another thing I paid close attention to on step 3 is the position of the bottom bar containing the back and the next buttons. I wanted it to always be visible even if the keyboard is open. Turns out the CSS position fixed doesn't take into account the mobile keyboard and still renders the fixed content behind and below the keyboard. Various modern CSS units were also of no help, and I ruled using web APIs like the mutation observer and the resize observer to be a bit overkill for such a feat. I did find something called the Visual Viewport API in the MDN docs, which one could use to simulate the equivalent of a theoretical CSS position device fixed, a fixed position which also takes into account scroll, zooming, resizing, and the keyboard presence of mobile devices. I did play around with it a bit, but it seemed like too much of a hassle and wasn't guaranteed to work. And so I ended up with a solution where when the keyboard is visible, I'm rendering the main content at the top of the page and the bottom bar right below the main content. When the keyboard is not visible, I'm placing the main content at the center of the page and the bottom bar at the bottom of the page. If I was building a mobile app with the React Native, I'm absolutely certain that there'd be a ready-made solution for this. However, obviously, no one's going to download an app just to submit a feedback form once in their lifetime. But I was surprised that I couldn't find anything like a React library for the web that solves this problem out of the box. Two potential UX improvements that I imagine doing in the future would be making the star ratings swipeable. I initially wanted to make it that way, but it turned out to be a bit more complicated than I expected because the way mouse over works on touch screens is not the way I expected and not the way it works with a physical mouse. So I will have to look into that. And another improvement I could see myself making is bringing back theme support. So initially I wanted to allow light and dark themes, but it turned out to be a bit more of a hassle, which is a bit of a surprise. But yeah, I wanted just to push out this project as fast as possible and ended up just ditching the light theme, although it looked quite pretty with that light theme as well. As per the tech, I chose to use React and Next.js and to use Formic for the form state management. I contemplated using Solid.js because I really like the framework, but decided to go with what I know best. And I also wanted to try out Next.js's app router and server components. For styling, I decided to try Tailwind and ShadCN for the UI components. I've never used Tailwind before, which might come as a surprise since I read and really enjoyed the book Refactoring UI, which was written by the creator of Tailwind. Overall, I get why so many people like Tailwind so much, but as someone who also knows how to achieve it all with just vanilla CSS, I did find myself using React's inline style objects a lot just for the sake of productivity. It was much faster for me to do things that way rather than looking up Tailwind's docs. Also, I found that for things like very specific CSS grid layouts, vanilla CSS is the way to go, and some of it I don't think it's possible to do using Tailwind classes. As for ShadCN, I did enjoy the concept of a UI component being generated inside the directory within your own source code, as opposed to importing from a library. And soon enough found myself going into the files and slightly modifying the behaviors of the generated components. For the database, I initially chose SQLite because the physical store receives about 100 customers per month. Even with all of them leaving a review, the amount of data is not so high that it warrants using a full-on DB server. I'll also mention that my intention was to host this project on a cheap virtual private server, probably on Vultr or DigitalOcean, and just store all of the data on the SQLite file and make backups. Vultr was the cheapest option, but I had issues during the sign up and the payment process, so it became just too annoying to attempt to host on their platform, which is a bit of a shame. While I did host the project on DigitalOcean's app platform, I found its features to be a bit limiting. And while I was trying to remember how to set up an Nginx reverse proxy with the free Let's Encrypt SSL certificate, I decided that I don't like SQLite's lack of support for any type of JSON data type, and the better SQLite 3 libraries need to convert booleans to string when inserting data. All of this led me to the idea of just hosting on Vercel. The backend would become a serverless function, and for the DB, I'd opt into using Postgres, hosted on one of the platforms that Vercel has an integration with, for which I ended up using Neon. Quick caveat is that I wasn't honestly aware how easy it is to integrate a serverless function with something like a Postgres database. I also decided to try Drizzle as the ORM, but to be honest, I have kind of mixed feelings about it. I found the type errors not to be very self-explanatory. It wasn't very easy to figure out which property had the wrong type from the TypeScript error messages that I was getting. The documentation on how to hook it all up and make it work with Vercel and Neon was scattered across the documentation pages of all three platforms, and it just took a bit more time than honestly should have. I'll also mention that after I had set everything up to work for production, it took more time than expected to set up the local development setup Vercel recommends, which involves using Docker Compose and the Docker images of Postgres and some Neon middleware image that manages the DB connection for Next.js via WebSockets. I was eventually able to set it all up, which meant that I could host everything for free while also having the great UX of hosting on Vercel. Also, using Postgres meant that I could store the form fields in a JSONB column, add new fields to the form and the JSONB column without needing database migrations, query the fields within the JSONB. None of this is supported by SQLite. One potential improvement in regards to the tech that I did feel I could have made, but at the end it was a bit too late to make it, was to use gRPC, which would have been just in general nice to have the type safety between the front end and the backend APIs.